So I told you previously we would deal with negative exponents. I know they may seem weird, but I think once you understand what they signify, it'll be a little bit easier. So positive exponents are the result of repeated multiplying or multiplication. Negative exponents are the result of repeated dividing or division. So based on what we've learned so far, we can evaluate something like x cubed over x to the fifth in two ways. We learned that when we divide the same base with exponents, we subtract the exponents. So we can do 3 minus 5, which is negative 2. Okay, now if we do the expanded form we talked about earlier, x cubed means you multiply x by itself 3 times. X to the fifth means you multiply x by itself 5 times. Then as we talked about also with the expanded form, you can say x divided by x is 1. X divided by x is 1. X divided by x is 1. Now, we're all out of x's on top, but as I said, when we divide these, it's 1. So we get 1 on top. But there's 2 x's on the bottom. X times x is equal to x squared. So if you look, we just use the rule we learned earlier, and we also use the expanded form to think about what do these two things really mean. We got 1 over x squared. If you look, we started with the same thing both times, and we just used 2 different methods to simplify it. So what that must mean is that x to the negative 2 is equal to 1 divided by x squared. So here's our rule. Assuming the base is not 0, and we use any whole number n, a to the negative n equals 1 over a to the n. Now, it says when a does not equal 0, so when a does equal 0, it's equal to 1. So anything, this is worth remembering for a long time, anything, any number, any variable raised to 0 power, the answer is 1. So let me address this first, then I'll try to explain, make sure you understand why anything to the 0 power equals 1. So when you see a positive exponent, that means that number or that variable is on top. When you see a negative exponent, that means that variable is on the bottom. So 8 to the negative 3 is the same thing as dividing by 8 to the third power. So that's why I said up here, a positive exponent means multiplying. 8 cubed means you multiply 8 times 8 times 8. 8 to the negative third means you divide by 8 times 8 times 8. So you might think, how in the world would we have a power of 0? So let's think of a number like 3. We'll go simple. So 3 squared over 3 squared. So there's 2 ways you can think about this. The division rule, when you have the same base, is that you subtract 2 minus 2. And 2 minus 2 is 0. But also, we know when you have a fraction and it's the same thing divided by the same thing, in this case 9 divided by 9, it's equal to 1. So what that 0 really implies is you have the same thing on top and the same thing on the bottom. So when you divide the same thing by the same thing, it's equal to 1. So the few different things I want you to be able to do with negative exponents. One is just rewrite it as a positive exponent. So in that case, you're just going to use this rule. The base to a negative power is the same thing as 1 over that same base to a positive power. So 2 to the negative 3 is the same thing as 1 over 2 cubed. So that negative means we're dividing by 2 cubed instead of multiplying by 2 cubed. This one will be 1 over m to the fourth. because instead of multiplying by m to the fourth, we're dividing by m to the fourth. Here, instead of 3 to the negative fifth, can be rewritten as 1 over 3 to the fifth. And anything raised to the 0 power is equal to 1. It can be the largest number you can imagine. If you raise it to the 0 power, it's equal to 1. Okay, now they tell us to write each fraction as an exponent using a negative exponent other than negative 1. So this is really us going in reverse from what we did on the first 3 we had. So we know 4 squared in the bottom we can write as 4 to the negative 2. Now, here's where we have to be careful with the directions. This is 100 to the first power. So it's not untrue to say this is equal to 100 raised to the negative first power. However, it says write each fraction as an expression using a negative exponent other than negative 1. So you got to think, all right, how can I write 100 as a power of something? In other words, what raised to what is equal to 100? Well, 100 is 10 squared. So if I change the 100 to 10 squared, then I can write that as 10 to the negative 2, and then I've followed their directions about using an exponent other than negative 1. Okay, number 3, 1 divided by x to the fifth is the same as x to the negative fifth. Now on number 4, we run into the same problem we had with number 2. It's true that this is equal to 27 to the negative 1, because that's 27 to the first power, but they want to use an exponent other than negative 1. So we've got to think, okay, what raised to what power equals 27? So it turns out 27 is the same thing as 3 cubed. Then we can rewrite it as 3 to the negative 3. So that would be our answer. This is mathematically the same as this. But since the directions said to write it using a negative exponent other than negative 1, that's why we had to change 27 to 3 cubed and get this. Now you can guess and check in your calculator. I'm never going to ask you to do more than a squared or a cubed in this. I'm not going to ask you to memorize or try to think about what to the fourth or what to the fifth. So you can guess and check if you need to figure these numbers out. Squared and cubed is as much as I'll ask you to do. Okay, evaluate the expression if a equals negative 2. So we do 4 times negative 2 to the negative fifth power. So we remember that we can rewrite this exponent as a positive exponent if we move it to the bottom. So this really means negative 2 times negative 2 times negative 2 times negative 2 times negative 2. And you can plug this in the calculator, but make sure you use parentheses if you do so, or else you get the wrong answer. Sometimes anyway. We get 4 over negative 32. Those are both divisible by 4, so we can divide the top and bottom by 4 and get 1 over negative 8. Or you could write with the negative on top. It doesn't matter if the negative is on top or on the bottom. Okay, on this one is 7, and we replace a with negative 2. 7 to the negative second power. We know we can rewrite that as 1 over 7 squared. And 7 squared means 7 times 7, and 7 times 7 is 49. Okay, similar problems down here, just have new values. So m equals 4, so I do 4 to the negative 3. That's the same as 1 over 4 cubed. 4 cubed means 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. Okay, here we've got a little more work to do, so we got to be careful. So m is 4, n is 3. So notice, the m has no exponent other than the understood 1, but the n has an exponent of negative 4. So I can just use 6 times 4 and get 24. And 3 to the negative 4 is the same as dividing by 3 to the 4th. And 3 times 3 is 9. 3 times 3 is 9. So 4 of them gives you 9 times 9, which is 81. So we got to think, okay, we have a fraction, but we've got to reduce it. What number goes evenly into both 24 and 81? Well, one of them would be 3. 24 divided by 3 is 8. 81 divided by 3 is 27. And there's no number that goes evenly into both 8 and 27. So that is our final answer.